Today I'm going to be doing my project portfolio, and the first checkpoint that I'm going to be discussing is double up. I'm going to start with main. So here we're making a array list of integers, and we're calling list.add for each of the numbers we're adding to the array list. And this array list is the initial array list that we are going to double later on. So this is just the numbers before doubling them. We call this add for each number we want to add to the list, and then we print that out. And then down here in string to string, this is where we kind of create the format of the array, and it's the first bracket, the end bracket, and then the commas that separate each number. And so the array goes through this whole process, and then we print it out right here. After we print it out, this is what we see highlighted, and then we go on to list.doubleUp. So the double up method is up here, and I'm going to move to the debugger to show you a more detailed way of how this is done. So I've already skipped past to the point where we print the initial array, and now we're at list.doubleUp, where we're going to use the initial array to create another array that is doubling each of these integers. So I'm going to step forward. Int n we declare is size minus 1, and size is 4. So size minus 1 is going to make n equal to 3. And we get this number from the size of our initial array, which is an index of 3, and there's 4 numbers. So next we go on to another declaration, which is int clone size, and that is size times 2. So 4 times 2, since size is 4, we're going to get 8. Okay, so there we go. And then we have this for loop right here. So we're making I equal to n, and as long as I is greater than or equal to 0, we're going to go into this for loop, and we're going to be counting down from this I minus minus. And so since n is equal to 3, we're going to be counting down from 3. So we go into this for loop. Size is equal to I times 2. I is 3, so times 2, it equals 6. Then we go into go on to add element data I. We declare add element data I twice because this is pretty much the way that we create our doubled up array list of doubling each number. So when we go to add element data I, the add method is down here. And as you can see, we're basically taking our size and we're assigning it to the value. So we're starting from the value of 7. So we're starting at the end of our array list, and we're working our way to the front. So once we create that, at the end, we're going to add 1 to our size. So basically our size is going to be twice the size of our first array. And then we just keep on doing that until we count down all the way from 3 to 0. So I'm just stepping forward here until we have all of our numbers done. So here we're at string to string. It's already calculated, it's already doubled all of our numbers, and now we're just separating the array, the numbers with commas, and we're putting it into an array. So, or we're putting it into brackets. So we're putting a beginning bracket and an end bracket. Right here it says if size is equal to 0, we're going to return brackets with nothing in it. So other than that, once we're done with that, we're going to print the array. And here we go, it's doubled right here. So there we go. Now I'm going to be walking you through my solution to the max occurrences checkpoint. So starting in main, we first make a list of integers, and we're adding each of these numbers to that list. So every time we call list.add with this number, we are adding that number to list. Once we've gone through and added all of the numbers, then we go to system.out.println max occurrences list. So when we call this, we go up here to max occurrences, and I'm going to show you this in the JGrasp debugger so we can look at it at a more detailed view. So stepping through, we go through all the numbers and add them to the list. Then we go to system.out.println max occurrences list. That takes us up to the max occurrences method, which takes a list of integers called list, which is what we declared right here in main. And when we step forward into this method, we create a hash map of integer, comma integer. So we're creating a hash map so that our key is an integer and our value is an integer. And we do this so that we can keep track of the value that our number is associated with in the map. So stepping forward, we're declaring an integer mode to 0. And then next we step, and so we're going through this for each loop, and we're going through each of the integers in list, and we're associating each of these integers as s. So we go into the conditions of this for each loop, and the first one is if int map contains key s, we're going to do this, which is we're going to associate that number s with that value of s plus 1. If this statement is not true, then we're going to go to else, and we're just going to associate the number s with the value 1. And this is because we're assuming that our list is not empty or null. So our value is going to be associated as 1 no matter what. It's never going to be associated as null or 0. It's going to be at least 1. So after that, we go to this if statement, and if the value associated with s is greater than mode, then we are going to make mode equal to that value, and then we step through, and if it is true, then that's what we're going to do. If not, we're going to keep going through this for each loop until each of our numbers have gone through it. And when we're finally done going through each of the numbers, we're going to return mode. And what mode is doing is it's keeping track of how many times a number occurs in the list, which is why we do this if statement. So if ever we get a number greater than mode, then we're going to make mode equal to that number, that value, because the mode is acting as like an accumulation. So we're accumulating the numbers of mode, and the highest number is going to be returned. So when we get down here, when we finally get to print out max occurrences list, we're going to print out 2, because 2 occurs twice in this list, which is the correct answer. I'm going to show you my solution to the unrotate checkpoint. Our goal in unrotate is to take a list of integers, like this, and to put the last integer in the front. So all of these subsequent values will be shifted 1 to the right. And that will look like this. So in my code, in main, we first make a new linked int list, and that is going to contain these numbers. So when we do this line, we go to this linked int list method, and this is what constructs the list with those given numbers up here. So after we have that done, I'm going to go to the Java visualizer so we can see a more detailed view of when we do list.unrotate and how that executes. So I've already skipped to the point where we've made a list node for each of the numbers in the list. Okay, so once we've already done that, it's going to go back up to main, and it's going to go to list.unrotate, and then we go up to the method. So the first condition is if front is not equal to null and front.next is not equal to null, then we're going to go through and execute these lines. So basically this if statement is checking if the list is empty or not. And as long as it's not empty, then we're going to go through with it. So in the if statement, we declare a list node temp equal to front. So front is obviously the first number in the list, so that's going to be 23. So temp is going to equal to 20, is going to be pointing to the list node that 23 is in. And then next, we make front equal to front.next. So front.next is the number next to 23. It's a node next to the front number. So that is 19. So front is going to be equal to 19. And then we make a list node current equal to front. So since we already reassigned the value of front to 19 instead of 23, current is now going to be equal to 19. So as you can see, current is pointing to the list node that 19 is in. And so when we do list node s is equal to temp, since we already declared temp is equal to front up here, at that time front was equal to 23. So we basically saved the value of 23. So temp is s is actually going to be equal to the list node 23 because that was front at the time before we changed that value to 19. And so when we go into this while loop, every time we go into it, it's checking if the next node is empty or not. So as long as it's not empty, we're going to go into this loop. So what that really means is we're checking if we're at the end of the list. And as long as there's a node in front of the current node that we're on, it's not empty. So if it is not empty, we're going to go through this loop and we're going to make s equal to current and current equal to current.next. So as we saw before, s was pointing to 19. So now we're reassigning s to current. So current was equal to 19. So they're the same value. So s is going to be equal to 19 and current is going to be equal to current.next. So current is pointing to 19, but current.next is the one in front of 19, which is 7. So current should be equal to 7 now. And that's what we do for each number in the list node. Go through all of our list nodes, every number in the list, because we need to get these values to assign temp, current, and s to. And we're going to use those later after we leave the loop. So once we reach the end of the loop, and we're at the end of our list, we get to current.next is equal to temp. So temp has been equal to 23, and current has a new value and is pointing to the list node 8. So current.next equal to temp is going to make current.next equal to 23. So that's why we're going to get a huge arrow pointing back to 23. And then temp is going to be equal to current. So current is 8. So temp is going to be equal to 8 now. So as you can see, the arrow is pointing all the way over to 8. And then s.next is going to be equal to null. That's pretty self-explanatory. And then front is going to be equal to temp. So our new front is going to be 8, since temp has the value 8. So this is where we're reordering our numbers so that the last integer is in the front, and we're shifting all of our values to the right. And so now we have all of our numbers in the order that we need them to be. And now we're going to go ahead and print our list. But first, before we print it, we need to go through and put brackets around it, and then put commas in between each number. So we go through every number to do that, and as you can see, our list is already being built right here, and so far it looks good. And that is correct. So now we print our list, and here we go. This is the right answer. You through my solution to the right chars checkpoint. So our goal in right chars is to print a series of symbols based on the number n we input. So here's an example. If we input 1, we're going to get 1 star. If we input 2, we're going to get 2 stars. But when we reach 3, this is where a more patterned output begins. So as you can see, when we start at 3, we get some carets on each side, and that continues for every number up. So as you can see, 3 and 4 have 1 caret on each side of the star, and then 5 and 6 both have 2 carets on the side of the star, and then 7 and 8 have 3 carets on the side of the star. So you can see a common pattern here. As we go up the numbers, every 2 increase by 1 for carets. And for stars, you can see that they alternate between 1 and 2, depending on the number, if the number is even or odd. If the number is odd, we have 1 star. If the number is even, we have 2. So in the code, in the main, we have right chars 3. So immediately we go up to right chars, int n is what it takes as a parameter, and we go into the condition. If n is less than 1, we're going to throw a new illegal argument exception. This means we basically aren't going to have any numbers less than 1 because that's not going to get us any symbols. So we don't really want to pay attention to numbers less than 1. If the number is 1, we're going to print out 1 star, and if the number is 2, we're going to print out 2 stars. So these 3 if-else statements are our 3 base cases. And if none of these are true when we go into the code, then we go into else. If we go into else, we first print out a caret. So this means if we're in this else statement at all, our number is at least 3. So as you can see, when we start at 3, we're going to have a caret. We're going to have a caret no matter what, any number above 3. So that's why you print a caret. The next line, we're doing recursion. So right chars n minus 2. If we have the number 3, for example, we're going to put 3 in place of n minus 2, and that will equal 1. So we're going to go back to the top for our recursion and pretend like we're doing 1 as n. So we're going to skip until we reach the base case n equals 1, because that's our number, and we're going to print out this 1 star. So then right chars 3 minus 2 is complete. Then we can move on to the next line, which is system.out.print an end caret. So we're printing an end caret because we're done with our recursion. And as you can see, number 3 has an end caret after that star, so it should be correct. So when we run this, we should get that exact answer. So now I'm going to be showing you my solution to the print numbers 3 checkpoint. And this has to do with recursive enumeration. The goal of print numbers 3 is for it to take a parameter of 4 numbers, A, B, C, and D, and it would print all of the integers that are composed of B number of A's and D number of C's on separate lines. So what that looks like is, if we have print numbers 1, 2, 3, 4, 2 is our B, and 4 is our D, which also makes 1 as our A and 3 as our C. So 2 means that we are going to repeat 1 2 times. And then 4 means that we're going to repeat 3 4 times. And we're going to print every combination of those numbers. So it would look like this. Okay, so now we're going to move to my code. In main, we have print numbers 3 with parameters 1, 2, 3, 4. So automatically, it's going to take us up to print numbers 3. And then the first condition is if A is less than 0, or B is less than 0, or C is less than 0, or D is less than 0, we're going to throw a illegal argument exception, because we don't want to deal with any numbers that are less than 0 or negative, so we're just assuming that our numbers are positive. So that's why we get that out of the way first thing, if we do. So after that, we're going to declare a string s equal to just quotation marks with nothing in it. And then we're going to go into this for loop, and we're making I equal to 0 and I less than b. So in this case, b is 2, and then we're counting up. So in the for loop, when we go into it, we're making s equal to s plus a. So since s was just empty quotation marks up here, we're going to add on a to that. So a is 1. So when you add nothing to 1, you just get 1. So now s equals 1. And then we go into that for loop one more time, and then we do s equals s plus a again. So s is equal to 1, so we already have that, and then we add a to it again. So now we have 1, 1, or 11. And then after that, we exit the loop. And then we do the same thing, but with different numbers. So we're doing d now instead of b. So d is equal to 4. So we're going to go through this loop 4 times. So we're doing the same thing. S is equal to s plus c now. So we have s equal to 1, 1 now. So if we're going to add on c, which is 3, we're going to have 1, 1, 3. And then we go through this loop again. We add c onto 1, 1, 3, and we have 1, 1, 3, 3. Then we do that 2 more times. And then we'll have 1, 1, 3, 3, 3, 3. So 2 1s, 4 3s, once we're done with the loop. Then after that, we go into get all. And I do want to state that the purpose of going through these loops is to create the first set of numbers. As you can see in the example, this is our first number that we print on the first line. And this sets us up for being able to create all of the other possible combinations that we print on the next lines. So that's why we needed to make this first number. So when we go to get all, I'm going to move to the Java visualizer so we can see this. And as you can see, we have 1, 1, 3, 3, 3, 3. We go into get all, and then we step into the get all method right here. We make a Boolean temp array so that we can keep track of numbers or permutations that haven't been or have been repeated. So we don't want any repeats. We want our numbers to be unique, and this prevents us from getting duplicates. And so then we go into this if statement. If s.length is equal to 0, so that means if our length is equal to 0, then that means we have a permutation. If not, we're going to go into the next for loop. And this for loop basically checks if we have that number already. And if we do, then we're not going to go forward. But if we don't, that means that we're going to recurse, because we don't want to recurse if we have a number that already exists, because we don't want duplicates. And we recurse until we have all of our numbers. And unfortunately, the visualizer isn't going to, the visualizer has exceeded its time limit with this code, so I'm just going to skip past to what the actual output is, and that will be just the example here. And I'll run it for you with my code. So there we go. I'll be walking you through my solution to the even branches checkpoint. So the goal of even branches is to take a binary tree and to count the number of branch nodes that contain even numbers. And a branch node has 1 or 2 children. So if we're looking at this tree, 2 obviously is a branch node because it sprouts out. 8 has 1 child and 1 has 1 child. 7 and 6 both have 1 child. But 0, 4, and 9 are both leaf nodes, which mean they don't have any children. Nothing is sprouting down from them. So in my code, we go down to main and we call system.out.println new entry. And this is a code to make your tree. So before we even start counting the even branches, this tree goes through a lot of other code to be constructed. And after it goes through that whole process, then it can finally go to the even branches method and count the number of even branch nodes. So when we go into even branches, it takes the tree, the entry node root. And so what we're saying in the first condition is if root is equal to null, then we're going to return 0. So if root is equal to null, that means that our tree is empty. If we don't have a root, if a root is empty, then we don't have anything in the tree. All trees need to have a root, and if it doesn't, then it's empty. And so as long as it's not empty, we're going to go into the else if, and we say if root.data is divisible by 2 and has no remainders, and root.left is not equal to null, or root.right is not equal to null, then we're going to return 1 plus even branches root.left plus even branches root.right. So basically what this else if condition is stating is it's checking if it's an even number first, and then it's saying if it has 1 or 2 children. So it could have both, it could have one or the other, but it just needs to have one, which is why we say if root.left is not null or root.right is not null. Doesn't need to be both. We just need one that isn't null. Then we're going to go ahead and recurse. And when we recurse, we just keep checking. We go down the tree and check every branch node that sprouts off. And that's why we recurse, because we are going all the way down and we're checking if they're even or not. And if it's not divisible by 2, if it's an odd number, then we're going to do this else. And we're still going to recurse. We're going to return even branches root.left plus even branches root.right. And so even if the number is odd, we're still going to be checking and going down the node until we finally reach the end. So as we see in the example here, only 2, 8, and 6 are the branch nodes that are counted because they are even and they have children. And we don't include 0 or 4 because those are leaf nodes and they don't have children. So the correct output is 3.